Hello guys, hope you all are having a good night so far. So yesterday I posted a couple videos about area. If you have not watched them yet, please make sure you take this time to go back, watch them, and then come back and watch the video. So don't watch this video until you've watched the other three, because we will be using the ways we're going to be talking about are going to be the ways that they use in the videos, but also we're going to talk about how they help us in the real world. So it's very important that you go back and watch those before you continue with this video. I'm going to assume that if you're still here, you've already watched the videos and you are good to go, so we are going to start. Now, we have three shapes here. One that has nothing inside, all right? So we're trying to find the space inside. The second one is colored in, so we can't really see the squares. And the third one is colored in, and it gives you the measurements. So we're going to start with the first one. And I've already told you that the units are 1 centimeter by 1 centimeter. Okay, so we are measuring in centimeters. And each block, so each block here, and here, and here, and this block, they're all 1 centimeter cubed. Now, the reason that one block equals 1 centimeter, not cubed, sorry, squared, 1 centimeter squared, is because when we're talking about length, that is straight, right? It's from point A to point B. That's length. And if we were measuring in centimeters, we would say centimeters. But when we're talking about an area, we already know the area, that's the space inside, right? So if you think about it, when we're talking about this one block, the length from the bottom to the top is 1 centimeter. And the length from the bottom right to the bottom left is 1 centimeter. Those are both length. The area inside is also 1 centimeter. Now that can't be possible unless we add that squared, okay? Because think about it. The area inside isn't going to be the same amount as the length. That's a little weird. So that's why we need that squared, because this is a two-dimensional space we are talking about. And because it's two-dimensional, we add that little 2. So, moving on. This space right here is what we're trying to figure out. Now, in the video yesterday, they showed you how you can use the blocks that are already there, if they are there, to help you. And that's what we're gonna do this time. So we're gonna say, all right, so each block is 1 centimeter squared. So if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have counted out 12 blocks that make up this entire shape. So basically what that's saying is that if I took and cut out this square, I could put it in this shape 12 times. So we already know that one block equals 1 centimeter squared. So 12 blocks equals 12 centimeters squared. All right, that makes sense, right? Because we could say, all right, 1 centimeter squared, 2 centimeters squared, 3 centimeters squared, 4 centimeters squared, all the way up to 12. So that makes perfect sense. So the area for this first shape is 12 centimeters squared. So now we're moving on to our second shape. Now this one I've also given you a block as reference. You know that this side is 1 and this side is 1, but you'll notice that this time I didn't give you a label. All right? I didn't give you a label. Here we had the label of centimeters, but here we don't have one. Now in math, you always want a label. And sometimes they don't tell you what they measured in. So we know this is a length. We know they measured it with something, but we don't know what that measurement was in. So in order to still give it a label, you give it the label unit. So this length is 1 unit, and this length is 1 unit. I know that might seem a little confusing, but whenever you are measuring something, I remember how I always say, what is it? 12 chickens, 12 ducks? No, it was 12, whatever it was, 12 cups or 12 glasses, okay? The same thing goes with area. We need to know how much space, and even though we don't know what that unit is, we know that it's some kind of measurement, and it has to have some kind of label, and we can't forget about that. So, now that we have our label, we know that it's a unit. We know that 1 block equals 1 unit squared, okay? 1 unit by 1 unit is 1 unit squared as the area. So now, one of the ways that they showed you that you could find the area for something that's shaded in, so you can't actually just count the blocks, is to split it back up into blocks. So what we are going to do is we are going to try that here. Now I don't know how well you can see this on the recording, but there's 1, 2, 3 blocks here, and 1, 2, 3, 4, 5, 6, 7 blocks here. So I'm going to take my orange marker and divide up the blocks. I'm going from the line at the top straight down to the line at the bottom. So I'm just going to go ahead and voila, we now have all our boxes. So like I said, there's 3 boxes here and 7 boxes here. Oops, sorry, not boxes, units. 3 units. Okay, so we have 7 units and 3 units. Now, we can go ahead and do the exact same thing we did in the first one and go, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way until we get the answer, which is 21. But I'm going to do something a little different this time. I'm going to think about it as groups. So, I want this, I'll use a different color for this one. I want this to be group 1. And I want this one to be group 2. And we'll use the brown for group 3. Okay, so I now have split up our shape into 3 different groups. If you notice, in the first group there are 1, 2, 3, 4, 5, 6, 7 units. Let's find out how many units are in the second group. 1, 2, 3, 4, 5, 6, 7 units. Look at that, it's the exact same. Okay, now we're gonna take a minute. How many do you think are in the third group? Y'all should have said the same amount, which is 7 units. So you guys notice that in each of these groups, there are 7 units. And the reason is because there are 7 units across the top. And the reason we have 3 groups is because there are 3 units going down. You might remember this from arrays, which is rows and columns. So we have 3 rows, row 1, row 2, row 3, and 7 columns. That's how many was in each group. Now, because we have equal groups, we can now do a multiplication equation, right? When we have equal groups, we can use a multiplication. And we can do multiplication. So, because there are 3 equal groups of 7, we can do 3 times 7. 3 equal groups of 7, which equals 21. And because we are talking about, all right, so yeah, 21. But then what are we missing? Of course, our label. So that is units. And y'all should have said that I'm missing something else. What is it? What is it? What is it? What is it? That's right, our little squared. Okay? Because remember, it's a flat surface, so we have to have that 2. It's a 2-dimensional shape. So if we have 21 blocks, that equals 21 units squared. And that goes back to if you had done it the way we had done the first one, you just counted out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 21. You would have had 21 blocks, which equals 21 units squared. So now we've gone 2 different ways to solve area for area. One was actually using the blocks they gave you. Another was using multiplication to help us. Now I want you to keep the multiplication one in mind as we do this one, okay? Because now we can't see what's inside. And because this is such a dark square, we can't separate it into the units, which in this case are feet. We can't separate it into 1 foot squared blocks, right? So this is going to be a little harder. I want you to think about what we did in this second problem, where the area was 21. And I want you to use what we did in the second problem to try and think of